Okay, hello my students. Your physics teacher Hassan Darwish with you. In this video, I'm going to solve a direct application about charging a capacitor. And in this exercise, I'm going to determine the capacitance C of a capacitor. That's why we connect here the electric circuit. This circuit contains an ideal generator, G, means its internal resistance is 0. Constant EMF, switch as you see, capacitor whose capacitance is to be determined, and a resistor R equal 100 ohms, right? We close the switch at the instant t equal to 0. So what happens when you close the switch? The capacitor starts charging, means its charge increases, but the charge is proportional to the voltage, U of M. So the voltage must also increases. Clear? Now, document 2 shows the variation of this voltage, U of M, as a function of time. Here is document 2. You see, U of M, the voltage increases from 0 till a maximum value and becomes constant, right? At 12 volt. Okay, good. So in part 1, shows that the value of the EMF of the generator is 12 volt. We want to show the voltage is 12 volt EMF of the generator. Let's start. Part 1. From the graph, as you see, for t greater than or equal to 10 seconds, the voltage across the capacitor is 12 volt is constant, right? We've just seen this. Now, if the voltage is constant, what happened to the charge? Yes, becomes constant. So the charge Q equals Cu, charge in the capacitor becomes constant. If the charge becomes constant, what happened to the current? The current is a derivative of the charge, means derivative of the constant. Becomes what? 0, right? Now go to the law of addition of voltages. U of the generator is equal U across the capacitor, which is U of M, plus U across the resistor, which is U and M, right? But this is, as you see, this voltage is nothing more than minus R I plus E, right? And this is 0, not because the current is 0 only, but because the generator is ideal, means its internal resistance is 0, equal U of M is what? Constant, right? 12 plus U and M, which is Ri. This is what? Ri. And I is 0. So this is equal to 0. Consequently, the EMF of the generator equal 12 volt. Right? Any problem? Okay. Part 2. Calculate at the instant 0 the current in the circuit. At equal 0, not equal 10 seconds, equal to 0. I go back to the same law here. Okay? So, sorry. Part 2, here it is. At equal to 0, the voltage across the capacitor is 0, right? Here it is. The voltage is 0. Okay? Good. So the voltage is 0 across the capacitor. If you replace here, this means that E, which is 12 volt, is equal to 0 plus R I. That's Ohm's law. Here it is. Ohm's law across a resistor, but at the instant 0. Okay? Now you can replace the value of R. I0 equal 12 over R, which is 100, then becomes 0.12 ampere. Okay, this is the electric current in the circuit at T equal to 0. Now part 3. Derives the differential equation describing the variation of the voltage across the capacitor, means at any instant between 0 and 12. Okay? So part 3, here it is. In part 3, we apply the law of addition of voltage, of course. Let me write it here. E equal U of M plus Ri, right? From this rule. This is the law. This is UG, which is E, equal U of M, which is UC, plus UR, which is Ri. Okay? But I, we've just verified that I equal derivative of the charge is Cu prime. Now replace it here. Replace this I here. What do you obtain? E equal, displace it a little bit. E equal U F M, which is UC, plus RC U prime. Okay? This is the differential equation. This is UC. Okay? First order differential equation containing UC and U prime C. Like this is at any t. Means time between time between 0 and 10 seconds. Okay? Right. So in part 4, we are given the solution of this differential equation, a plus b exponential minus t over tau. Determine the constants a, b, and tau in terms of r, c, and e. Okay. Part 4, we are given this solution. UC, this is UC, equal a plus b exponential. If we want to determine, because UC is a solution of this equation, it has to satisfy it. Means left-hand side of the equation must always be equal to the right-hand side. And this solution must verify this equation. But in this equation we have UC and U prime C. So first of all, we have to make derivative here. So do the derivative. U prime C, derivative of the constant A is 0, right? Plus B is another constant. Now, what's the derivative of the exponential? You remember the rule. Exponential e power u, where u is the function, becomes under derivative u prime e power u. That's the derivative of the exponential. And here is u. So make derivative, we get minus 1 over tau, because derivative of t is 1. Minus 1 over tau exponential minus t over tau. Applying this rule, right? So it is equal to this. Now, Let me displace it a little bit. E equal A plus B exponential. This is what? This is U here. Minus, because here we have minus. RC, this is RC. U prime. Okay? And this is U prime. So make it more beautiful. This will imply E equal, erase here, E equal A plus 1. I have taken B exponential here, exponential as common factor. This is as common factor. We get this. But this equation is satisfied for every time. It means what? It means E, which is the constant, equals A and 1 minus RC over tau, equals 0. Why equals 0? Because the left hand side here of the equation doesn't have an exponential function. There is exponential here, and here no exponential. For the two parts of the equation to be equal, the coefficient of the exponential must be equal to 0. And here is the coefficient. So solve this, you get tau equals RC. Okay? And this is always the rule. Part 5, sorry. Here is part 5. Determining graphically the value of tau. We know from the definition of the time constant tau that at the instant at t equal tau, when the time becomes equal to tau, in the charging of capacitor, the voltage across the capacitor reaches how much? Reaches 63% of E. It becomes equal to 0.63 of E. And E is 12 volt. Now multiply 12 volt by 0.63, you get 7.56 volt. Now go back to the graph and see for this voltage what is the value of the time here. So at 7.5 almost, here it is, the voltage is, the time is 2 seconds. Clear? So tau equal 2 seconds. Okay? Part 6. Deduce the value of C. We have just determined tau equal RC. So if you replace C equal tau, which is 2 seconds, over R, which is 100, you get C equal 0.02 farad. Okay? Easy job. Very simple calculation. See you in the next video. Take care. Bye bye.